Introduction to DML statements in Salesforce. Salesforce development offers a wide range of powerful tools and features to manage and manipulate data effectively. One such crucial aspect is the data manipulation language, DML, statements. DML statements are the building blocks that allow developers to create, update, delete, and retrieve data within Salesforce. In this article, we will explore the intricacies of DML statements in Salesforce and uncover the best practices to harness their power. Understanding the basics of DML statements. Before diving into the world of DML statements, it is essential to grasp the fundamental concepts. DML statements are used to interact with the database in Salesforce and enable developers to perform various operations on records. The key DML statements include insert, update, delete, and upset. Insert is used to create new records, update modifies existing records, delete removes records from the database, and upset performs an insert or update based on whether the record already exists. Understanding these statements is crucial for effective data management within Salesforce. Common DML statements in Salesforce. Let's take a closer look at the common DML statements used in Salesforce. Insert. The insert statement allows developers to create new records in the database. It requires specifying the object type and the field's values to be populated. An example of an insert statement in Salesforce would be account new account equals new account, name equals Acme Corporation, industry equals technology, insert new account. Account new account. This declares a new variable named new account of type account. In Salesforce, an account is a standard object representing a business account. This line is creating an instance of the account object. New account, name equals Acme Corporation, industry equals technology. This part of the line is responsible for initializing the fields of the account object. It uses the new keyword to create a new instance of the account object, and the values inside the curly braces represent the initial values for the object's fields. In this case, the name field is set to Acme Corporation, and the industry field is set to technology. Insert new account. This line is responsible for inserting the newly created account object, new account, into the Salesforce database. After this line is executed, the new account record will be stored in the Salesforce database as a new account record with the specified field values. Update. The update statement enables developers to modify existing records in the database. It requires specifying the object type, the record's ID, and the field's values to be updated. An example of an update statement in Salesforce would be account existing account equals select ID, name, industry from account where name equals Acme Corporation, limit 1, existing account, industry equals manufacturing, update existing account. Account existing account. This declares a variable named existing account of type account. It is used to store the result of the query, which is expected to return an existing account record. This SOQL query retrieves an account record from the Salesforce database. It selects the ID, name, and industry fields from the account object where the name is Acme Corporation. The limit 1 ensures that only one record is returned even if there are multiple matches. Existing account, industry equals manufacturing. This line updates the value of the industry field of the existing account variable to manufacturing. It's modifying the in-memory representation of the account record. Update existing account. This line is using the update DML statement to update the existing account record in the Salesforce database. The update statement is necessary to persist the changes made to the record in the Salesforce database. Delete. The delete statement allows developers to remove records from the database. It requires specifying the object type and the record's ID to be deleted. An example of a delete statement in Salesforce would be account to delete equals select it from account where name equals Acme Corporation, limit 1, delete account to delete. Account to delete. This declares a variable named account to delete of type account. It is used to store the result of the query, which is expected to return an existing account record. This SOQL query that retrieves an account record from the Salesforce database. It selects only the ID field from the account object where the name is Acme Corporation. The limit 1 ensures that only one record is returned even if there are multiple matches. Delete account to delete. This line uses the delete DML statement to delete the account to delete record from the Salesforce database. The delete statement is used for removing records from the database. UPSERT. The UPSERT statement performs an insert or update operation based on whether the record already exists. It requires specifying the object type, the external ID field, and the field's values to be inserted or updated. An example of an UPSERT statement in Salesforce would be: this Apex code checks if an Acme Corporation account exists. If yes, it updates its industry to manufacturing and performs a database update. If no existing account is found, it creates a new Acme Corporation account with manufacturing as the industry and inserts it into the database. The conditional structure ensures proper handling based on the existence of the account. Understanding these common DML statements lays a solid foundation for effective Salesforce development. Best practices for using DML statements effectively. To maximize the effectiveness of DML statements in Salesforce, it is essential to follow certain best practices. By adhering to these best practices, developers can harness the full potential of DML statements and achieve efficient data management within Salesforce. Handling exceptions and errors with DML statements. While working with DML statements in Salesforce, it is crucial to handle exceptions and errors gracefully. Salesforce provides robust error handling mechanisms to ensure data integrity and prevent application failures. The key to handling exceptions and errors is utilizing try-catch blocks. When executing DML statements, various exceptions can occur, such as DML exception, limit exception, and query exception. These exceptions can be caught using try-catch blocks, allowing developers to handle them appropriately. The catch block can perform actions like logging the error, displaying user-friendly messages, or rolling back the transaction. For example, the try block contains the code that might generate an exception. In this case, it attempts to insert a new record of type new account into the database. If an exception of type DML exception is thrown during the execution of the code in the try block, it is caught by the catch block. DML exception is an exception type in Apex that is specifically for handling errors that occur during data manipulation language (DML) operations, such as inserts, updates, deletes, or merges. If a DML exception is caught, the code in the catch block is executed. System, debug, an error occurred, plus a get message logs a debug message with the details of the exception. By effectively handling exceptions and errors, developers can ensure data integrity and provide a seamless user experience. Advanced techniques for manipulating data using DML statements. DML statements offer more than just basic CRUD operations. They provide advanced techniques for manipulating data within Salesforce. Let's explore some of these techniques. Field level security, FLS. Before performing DML operations, it is crucial to respect the field level security settings defined in Salesforce. Use the schema class to check the accessibility of fields and avoid unauthorized modifications. This Apex code checks if the name field of the account object is updatable. If it is, it assigns a new name to an account record and updates it in the database. This ensures that the code only attempts to update the name field if it is allowed by the schema. Partial updates. Instead of updating all fields of a record, DML statements allow developers to update specific fields only. This can be achieved using the database update method with the field set parameter. This Apex code retrieves an account record from the database with the industry set to technology. It then updates the account's name to new name and performs a selective update only on the name field using the database update method, capturing the result in a database save result variable named result. This allows for efficient field-specific updates and provides information about the success or failure of the operation. Database methods. Salesforce provides additional methods within the database class to enhance data manipulation. These methods include database, insert, database, update, and database, delete. They offer additional functionalities like all or nothing behavior, error handling, and bulk processing. By utilizing these advanced techniques, developers can manipulate data more efficiently and tailor their DML operations to specific requirements. Optimizing DML statements for better performance. Efficiently optimizing DML statements is crucial for achieving better performance in Salesforce development. Here are some tips for optimizing DML statements. Reduce queries. Minimize the number of queries required before performing DML operations. Utilize selective queries in query optimizations to fetch only the necessary data. Bulkify operations. Process records in bulk instead of individual operations. Bulkifying DML statements significantly reduces the number of database round trips and improves performance. Use collections. Utilize collections like lists and maps to store and manipulate data. This allows for efficient bulk operations and reduces redundant code. Avoid nested DML. Avoid performing DML statements within loops as it can lead to governor limit violations. Bulkify your code to handle collections of records in a single DML operation. By following these optimization techniques, developers can ensure faster execution and better utilization of Salesforce resources. Testing and debugging DML statements in Salesforce. Testing and debugging DML statements is a crucial part of Salesforce development. To ensure proper functionality and identify potential issues, developers should adopt the following practices. Unit testing. Write comprehensive unit tests to validate the behavior of DML statements. Cover different scenarios and assert the expected outcomes to ensure reliable functionality. Mocking data. Use mocks or test data factories to create test data for DML operations. This allows for controlled testing and avoids interference with production data. System debug. Utilize the powerful system debug method to log information during the execution of DML statements. This helps in identifying potential issues, understanding the flow of operations, and troubleshooting errors. Checkpoints. Insert checkpoints at various stages of the code to verify the state of records and variables. This helps in pinpointing issues and understanding the impact of DML statements. By incorporating thorough testing and effective debugging techniques, developers can ensure the reliability and robustness of their DML statements. Resources for learning more about DML statements in Salesforce. To further enhance your understanding of DML statements in Salesforce, here are some valuable resources. Salesforce Developer Documentation. The official Salesforce documentation provides in-depth information on DML statements, best practices, and advanced techniques. Trailhead. Salesforce's Trailhead platform offers interactive learning modules and trails for developers of all levels. Salesforce Developer Documentation. The official Salesforce documentation provides in-depth information on DML statements, best practices, and advanced techniques. Explore the Salesforce Developer website for comprehensive guides and reference materials. By utilizing these resources, you can continuously expand your knowledge and expertise in DML statements and Salesforce development. Conclusion. Mastering DML statements is essential for unlocking the full potential of Salesforce development. From understanding the basics to exploring advanced techniques, we have covered the fundamental aspects of DML statements in Salesforce. By following best practices, handling exceptions effectively, optimizing for performance, and adopting proper testing and debugging techniques, developers can harness the power of DML statements to manipulate data efficiently and create robust applications. Continuously explore resources, engage with the community, and practice your skills to become a proficient Salesforce developer. Thanks for watching.